Okay, so after mo malaman yung difference between your systematic error and then your random error and then your sampling uncertainties as well as the importance of sampling uncertainties, now it's time for you to collect your sample uh, through sampling, syempre, and then what you will collect is your gross sample. So to start off, so the gross sample is ideally a miniature replica of the entire mass of material to be analyzed. In this figure, so makikita nyo na meron kang river which have multiple channels that are supplying water into the main river complex. So dito meron kang apat. So ito, kung nakikita siya sa video, ito, at ito. So ngayon, kapag ka nag-sample ka, so dapat maging representative siya ng entire mass of this river system. So yung gross sample mo is collection of individual sample units. So kung makikita natin, so meron siyang apat na sampling points. So magsisimula dito sa entry ng NDPA dito. Tapos hanggang dun sa mouth ng river, papasok ng Atlantic Ocean. So bakit dito yung naging apat na sampling points? Kasi pagka naglagay ka ng sampling point dun sa for example dun sa pinakauna, so baka hindi mo ma-represent adequately yung mga other channels na nagpa-flow into the main river system. So, ganun. So, it must be representative of the whole in composition and in particle size distribution. So, yan. So, sa sampling na to, so, syempre, meron ka pa din may introduce na errors kasi halimbawa yung magiging contribution ng Atlantic Ocean into your sample. So, pero I think this is the best sampling that you can perform for this river system. So there are several factors that affect the size of the gross sample. So, so the first is the uncertainty that can be tolerated between the composition of the gross sample and that of the whole. So yan nga, yung nasa kapilang slide mo. So kailangan mo i-consider kung gaano ba kalaki yung uncertainty na i-introduce ng having different sampling points and then different channels for your river. So, yung different channels na nagpo-flow sa river mo, so nagpapalaki yun sa gross sample na kailangan mong buuin as well as yung contribution ng Atlantic Ocean. So then, the degree of heterogeneity of the whole. So kapag meron kang sample na hindi homogeneous kapag pagka kinolect mo. So for example, your leafy vegetables. So kapag kasi yan, i-dry mo yan and then yan ay yung ipinrases, so magkakaroon ka ng fibrous part and also magkakaroon ka ng part na mapapowder. So in that case, meron ka ng heterogeneity agad. So between the fibrous part and the completely powdered part. So kung gusto mong i-upset yung error na inintroduce itong heterogeneity na to, so kailangan mong lakihan yung magiging sample size. So pangatlo, the level of particle size at which heterogeneity begins. So, so may mga samples naman kasi na mas maliit yung magiging boundary of heterogeneity. So unlike your sample of leafy vegetables na talagang makikita mo with your naked eye yung heterogeneity ng solids na mapo-form after grinding. So may mga samples na it's possible na mas maliit yung kailangan mo maging gross sample. So, particles and gross sample. So the number of particles n required in a gross sample ranges from few particles to 10 to the 12 particles. So, syempre, yung mga sample na relatively homogeneous and then small lang yung concentration of analyte. So, for example, your halimbawa sa pond and then you want to analyze heavy metals. So, kukunti lang naman yung concentration na iyong analyte. So, makaka-apekto yun sa kailangan mong kuhanin uh, na number of particles for a gross sample. Kasi as you as you decrease your gross sample size, so also kapag nasa ppb sa parts per billion concentration na yung iyong analyte, so it's possible na wala nang masasaling analyte, lalo na kung hindi naman siya homogeneously distributed. So next bullet, the magnitude of this number depends on the uncertainty that can be tolerated and how heterogeneous the material is. So yan lang yung diniscuss ko dun sa bullet 2 and bullet 3 on the last slide. So third bullet, the need for large number of particles is not necessary for homogeneous gases and liquids. So yun nga, andyan na yung keyword. So homogeneous na yung iyong system. So you can expect na kahit napaliitin mo yung number of samples na kukolektin mo, it is still a representative of the whole. So, hindi mo kailangan ng large number of particles. So, the laws of probability govern the composition of a gross sample removed randomly from a bulk of material. So, there will be a separate video after this, and then we will resume our discussion on the slide after to summarize the assumptions of that video. So, ito na yung gross sample calculation. So, punta muna kayo dun sa another video and then balik na kayo dito after nyo mapanood yung video na yun. So, dun sa gross sample calculation, it's a derivation. So, meron tayong mga key concepts doon na dapat nakalagay dito. So, a two-sample mixture is assumed to simplify derivation. So, kapag ka nag-analyze tayo, so we always have our analyte and our matrix. So, para ma-simplify yung derivation, para wala kang maraming components. So, for example, you have your component A analyte and component B na filler, matrix 1. So, and then component C, a matrix 3. So, habang to wala mo yung pino-consider mo components, mas humihirap yung derivation na gagawin mo. Whereas, pwede naman kasi natin ilang lahat ng other components as component B. So, component B is just your matrix. So, second bullet, a single particle size is assumed. So, ito, essential to kasi kapag tayo ay nakakaroon ng probability distribution, so it's possible na meron kang iba't ibang particle sizes, lalo na kapag solid yung iyong minamanage. And then also, kapag kahit na liquid or gases yan, you have different components. So for example, in the air, you have 78% nitrogen and then 21% oxygen. So it has different particle sizes. So to just simplify the derivation, so ginawa na lang natin na single particle size. And then, itong single particle size na to ay inassume to be the largest particle. So, bakit largest particle? Kasi kapag ka ikaw ay halimbawa nag-extract ka, so nakaka-apekto kasi yung surface area into the extraction efficiency. So mas maliit yung particles mo, mas malaki ang magiging total surface area exposed. Kasi pagka nag-extract ka, kailangan pag-touch yung solvent mo into your particle. So yan. So bakit largest particle yung napili? Kasi yung smallest particle ang napili, so mas maliit yung magiging gross sample mo. So it will open up opportunities to have error. So kasi pagka gano'n, magkakaroon ka ng underestimation kapag yung mga larger particles mo ay hindi na consider. So whereas kapag naman yung largest particle ang kinonsider mo, so parang ano na siya, considered na niya yung mga smaller particles. So kaso ang magiging drawback nito is hindi siya efficient kasi yun yung malaking particle ang basihan mo. So, it's either lalaki yung gross sample na kukollect mo or it will call for removal of more particles than necessary kapag ikaw ay may limited collection capacity. So the last bullet is the mass of the sample has direct proportionality with the volume. Hence, reducing particle size has a large effect on the mass of the gross sample. So ito na nga yung sinasabi ko. So pagka yung particles mo ay may mas malaking volume, so meron siyang direct proportionality. So, mas malaki yung volume, mas malaki yung mass. So, yung larger particle, mas malaki yung mass na kailangan mong kunin than necessary. So, kasi yun yung ginawa mong basis para hindi ka magkaroon ng loss of sample. So, now, so we have one sample problem. So gagawin ko din to as another video. So you just watch that another video, and this is just a copy of the problem because I don't want to write this on the whiteboard. So that ends this lecture. Thank you for listening.